We will start the chapter 5, transport layer. Transport layer is the fourth layer in the OSI model. So today's video will be on the transport layer. This chapter will be separated in a two part. The first part will be transport layer. The second part, in the second video, like that means in the next video, that will be the part 2 of chapter 5. In this video, we will discuss about Dijkstra's algorithm, one of the most important question from computer networking. So let's start today's video. Okay. So the transport layer is the fourth layer in the OSI model, responsible for reliable data transfer between the processes on different hosts. It ensures end-to-end communication, error checking, data flow control, and connection management. Unlike a network layer, it manages packet transmission between devices. So let's see process-to-process delivery. Process-to-process delivery is the in the transport layer role in ensuring data is received to the correct applications or service on the destination device, using port members to direct data to the correct process on the receiving machine. So let's see UDP, or user datagram protocol. It's also very important. That's why it's very important. So just note it down. UDP is a connectionless, lightweight protocol that offers fast, simple data transmission without connection establishment or guarantee, making it ideal for applications prioritizing speed over reliability. So let's see the UDP. So we just discussed what is UDP, or user datagram protocol. Let's see the features of UDP. So first feature is no connection setup. UDP sends the data without establishing a connection between sender and the receiver. Second one, there is no reliability. UDP doesn't provide acknowledgement. UDP doesn't provide acknowledgement, retransmissions, or flow control, so making it less reliable. So basically, the feature doesn't mean it's a benefit. Those are some of the points that are noticeable in the UDP things. UDP is not reliable, not that reliable, no connection setup, and third one is low overhead. Because of its simplicity, UDP is faster and has less overhead than TCP. So what is the use case? Real-time application, online gaming, live video, audio streaming, DNS lookups, where speed is more important than data reliability. Yeah, that's normal. So the next is TCP and Transmission Control Protocol. TCP is a connection-oriented, reliable protocol that ensures data integrity and reliability by providing error recovery, flow control, and congestion control, ensuring data transmission without error. Let's see its feature. So the features of TCP, or Transmission Control Protocols, are connection-oriented. It's really connection-oriented. TCP establishes a connection before transmitting data, ensuring a reliable communication path. Second one is then its reliability. It ensures data arrives intact by using acknowledgement, transmission, and sequencing of packet. Then flow control. TCP uses flow control to avoid overwhelming the receiver by regulating the rate of data transmission. Then congestion control. TCP monitors network traffic and adjust the rate of the data transmission to avoid congesting the network. So the feature in the reliability, we saw that it ensures data arrives by using acknowledgement transmission and security sequencing of packets of flow control. TCP uses flow control to avoid overwhelming the receivers by regulating the rate of the transmission. And congestion control, TCP monitors network traffic and adjusts the rate of the data transmission to avoid the network. Then use cases, reliable communication. An application like web browsing, HTTP, HTTPS, file transfer, FTP, and email, SMTP, rely on TCP for accurate, reliable delivery. Then we have congestion control algorithm. Congestion occurs when excessive data overloads a network, causing less packet loss or delays. The congestion control algorithms match traffic to prevent or mitigate congestion. Then we have leaky bucket algorithm. So leaky bucket algorithm and token bucket algorithm are two important algorithms in the network layer. Sorry, in the transport layer. So those are. Let's see what is leaky bucket algorithm. The concept: the leaky bucket algorithm maintains a steady data flow rate, leak out, allowing water to leak out at a fixed rate, resembling a bucket with a small hole at the bottom. So, leaky bucket algorithm, basically, this algorithm is the whole fact is compared to a bucket of water, simply a bucket of water. Like what we see in a bucket of water, the water comes in a fixed rate, a particular rate. The water comes to the bucket, it fills the bucket, and suppose there is a small hole at the bottom of this bucket. So through this small hole, the water will be slowly coming out and dropping down, like slowly, so slowly, in a fixed rate, one by one every drop is coming. But when the water is pouring inside the bucket, the rate is like unstable rate. Sometimes it's come, come fast, like so fast the water is coming, or slow, unstable speed. But when from the small hole the water is coming out, dropping down, it's a fixed rate. So let's see the figure of leaky bucket algorithm. So this is the leaky bucket algorithm. So no matter at what rate water enters the bucket, this is the bucket and there is a small hole in the bottom of this bucket. So this is the leak and water is leaking down. The water drips out of the hole at a constant rate. So this rate of data, in the same way, in leaky bucket algorithm, the data is coming at a unstable speed, and no matter how, in what rate of speed the data is coming out. But when the data is going out from this is a constant and fixed rate, just like the water dripping out from the leaky bucket. Okay, so the same idea can be applied to the packet conceptually, just like I said. This is a host computer, it's a packet, and it is an unregulated flow. It's unregularly the data is coming in the bucket. This is not actually bucket, it interfaces containing a leaky bucket. It is compared to the bucket like water bucket. And this is the unregulated data flow, and regulated data flow after the data is going out from this bucket. This is the network, this is regulated flow. The working of the leaky bucket is incoming data packets are added to the bucket or buffer. Data leaks out at the constant rate. If the bucket overflows, if the bucket overflows, means too much data arrives too quickly, the excess data is discarded, preventing congestion. Okay, So the use case, what is the use case of leaky bucket algorithm? The leaky bucket algorithm is primarily used for traffic slipping, smoothing out burstly traffic to ensure a constant data flow. So let's see our second algorithm, token bucket algorithm. So just like this leaky bucket algorithm, we have the same concept, just a little difference, that we use token, the data as the part of token. So what is the concept? The token bucket algorithm enables data burst through steady rate generation of token in a bucket, allowing for flexibility in data rate control. So let's see the figure of token bucket. So let's see, this is the figure of token bucket algorithm. So this is the network A and this is the network B. So in case of the token bucket algorithm, we have a host computer here, and data is coming in a form of tokens to the bucket. So one token is added to the bucket in unit, every delta unit. The bucket holds the token. So this is, you can see there is the token in the bucket, and this is the network. And in the another way, it holds token generated by a clock at a rate of one token every delta second, just like I said. Then host computer, the token is coming from the host computer, it stores in the leaky bucket and it's coming out. So this is token. So token bucket algorithm. Let's see the working of token bucket algorithm. So in the working, we see that the tokens are added to the bucket at a constant rate at a delta second unit. Then when data is ready to be sent, tokens are sent accordingly to the size of the data packet. So if not enough tokens are available, data transmission is displayed, but short bursts are allowed as long as enough tokens are present. So this is all about the token bucket algorithm. Let's see the use case of the token bucket algorithm. The token bucket algorithm is utilized for traffic policing and SEPing, enabling data burst while maintaining a controlled overall rate. So this is all about the today's video. We will discuss a little about the quality of service, or QoS, and its techniques in the next video. The third part will come of this chapter, in which we will discuss only the algorithm, disjust algorithm and Bellman-Ford algorithm, two important algorithm that will surely come into your college and university exams. So this is very important. So thank you for watching this video. Give a thumbs up if you like this video. So see you in the next video, and subscribe to my channel and hit the bell icon. Goodbye.